Hey everyone, welcome to another episode of Microchip Livestream. My name is Matt Dickens and I'm the host for this awesome online event. I'm here with my co-hosts today, Andreas and Jian, and we're talking about how to get started with capacitive touch. So before I send us to the back, who are you and what makes you the experts in capacitive touch?
That's a very fair question. We are from the Microchip Touch team. My name is Andreas. I'm from the marketing side of things.
I'm Xiang from the application, so I'm doing the capacitive sensing solution technologies development and customer support.
Sweet, awesome. Well, excited to jump into it today. Before we get started, as always, I'm going to send it to the back of the booth, and my co-hosts back there are going to tell us a little bit about how you guys can participate today.
Hello, and welcome.
Hey, everybody.
My name is Rachel Bajor, and I'm here with Wayne Freeman.
All right. We didn't practice this, just so you know.
It's Wayne's first live stream.
But yeah, we'll be checking out the chat, so we'll relate the questions from the chat to our hosts at the front. So make sure you're chatting and commenting in there. And and we do have a giveaway today. It is the water-tolerant 2D Touch Surface Development Kit, PIC MCU Edition. They'll actually be showing it up front shortly.
Yep.
We have 5 of them, so we'll comment in the chat and we'll enter you to win, and we'll announce the winners at the end.
That's a good incentive to stay active. By the way, make sure that if you're not already subscribed to the channel, subscribe, hit the notification bell, and by the way, after this, you and Matt are heading out to the east coast of the USA.
Yes, directly after this. We are literally going to the airport after this. We'll be in Boston tomorrow at IoT Hardware Pioneers Conference. We'll have some giveaways there too. So if you guys are local to Boston, definitely check that out.
Definitely stop by and see them.
Yeah, it'll be me and Matt.
Get to see us in the flesh.
All right.
Awesome. Well, yeah, so as we mentioned, how to get started with capacitive touch. I know that that's something that a lot of people, as they begin to get into development, that becomes very immediately a challenge that they have to try to solve for themselves. So let's get started, Andreas, with just kind of why touch? Like, why is it important nowadays, and what are people using it for?
Touch can really improve the appearance of your product.
Okay.
I want to give you some examples. Can we show the slides, please? You will see, or the audience will see, these are 2 identical products, more or less. If you read the data sheet, they go to the cloud, they talk to your energy provider, they optimize when you pay more for the energy, when less, all of that. Which one, or if you look at these products, what do you see?
I see one that I think that I saw in my grandma's house, and then I see one that I put in my house.
Right, one made a time transition out of the 70s and one looks rather modern.
Right.
And the difference, even if they are feature pretty much the same, the difference is the user interface, the difference is to go for touch, for a sleek closed surface. This is when you as a customer, you go into a store and this is that product, the right one tells you, buy me, and because I have all the stuff you want. And the left one did a very good job in hiding all these good features.
Right. Yeah, awesome. So aesthetics for sure important. I know a little bit, you were telling me earlier about a story of not just aesthetics, but actually an expectation that there is with touch as well.
Yes, I think this generation we connect with touch like a good performance, like a high-end product. Next generation of people will expect touch. I give you a short story from my son. When he was like 3 years old, he found first generation Kindle.
Okay.
Your reading device, and you have the button to change the pages. Now what he did was he did the iPad approach, so he took the Kindle and started to slide. And then he came to me, Daddy, it's broken. Try to explain to a 3-year-old that not every screen is a touch screen.
Right.
So this is where we are going to be. This is where we are going to. So preparing today with touch interfaces will be good for revenue in the future.
Absolutely. It helps fit in with the whole expectation and user design and all that kind of stuff. Are there any reasons why I would use touch that aren't necessarily like about the look or about the feel, but like any really practical, like technical reasons why touch can actually provide an advantage to me?
Absolutely. There's one aspect which is easily forgotten. If you go for a product which is IPX rated, which means it's maybe dirt-proof, waterproof, something like that. So you're looking for some kind of sealed surface. If you go for mechanical buttons, the first thing you have to do is you have to make openings into your surface.
Oh, right.
So this is kind of counteracting your target to have a sealed product. So now you bring your buttons in, then you bring the rubber gaskets in order to seal them. You have to pay the tools for them to create them. You have to select the right materials, that they're still doing the sealing job like in 5 years from now. All these worries, all these thoughts, all that money to make that happen is not on the table when you start with a closed surface from the beginning, and this is something touch button can give to you.
Yeah, awesome. So aesthetics, expectation, and also just the practical protecting my physical design from dust and things like that. As we all know, dust can be a huge killer of any project, so the less dust in the system, the better. Great. So where do you kind of see touch in the marketplace at large as you're kind of going through your day-to-day life, like especially even in areas that we wouldn't necessarily expect it?
Today, touch is truly everywhere. I mean, it all started with our phones, and then everybody has, I think we have 80 million German people. I'm from Germany, and 85 million activated phones.
Wow.
So you
can that's more people, that are more phones than people, right?
I think that's not a German thing, that's more like a worldwide thing these days. So we have touch everywhere, but we also have touch in products where you're not necessarily expected. We have an example here, which are headphones.
Okay.
So now, several years ago, headphone looked very much the same, but they had a cable.
Right.
And it connected to a connector, which is not even part of our phones anymore.
Okay.
So that cable was pretty annoying, but it also had a nice feature, which was the remote, where you could stop the music and change volume.
Yeah.
Where do you do this on a wireless headphone, where you don't have a wire to connect the remote control to? If you go for mechanical buttons, we are all humans, we kind of look front, we have the ears on the side. So a button on a headphone you would not see.
Sure.
You have to feel for it, and while you do this, you are tapping your headphone, which creates noise. It's not a good user interface. A modern headphone goes for touch, so you make a simple upward swipe to increase volume. You would make this downwards for decreasing, left swipe, right, previous title, next title. You activate Siri. All these stuff you can do with a sleek touch interface, and you don't see any buttons. Again, you have no openings, and you have to find your ear, and then you move up. So it's not that you have to find a tiny button.
Right. Hopefully, we all know where our ear is. If you don't, then maybe you shouldn't be designing with touch in the first place. Other things to work on. And it's actually really cool that you bring that up. I know, Jiang, in a little while, we're going to be talking about kind of how to actually literally do that. So how do you prototype a design that can touch and stuff like that? So excited to learn more about that. Great. So we talked a little bit about, I use touch from the aesthetics perspective, from the practical perspective, and I know we even mentioned earlier when we were talking that when you have headphones that don't have buttons, that allows you to do things really practically with the headphones, like run in the rain, or sometimes if you're working out, the gym is not always the cleanest place, and so the less ways for things to get in and affect your system, the better. Awesome. So Jian, why don't you tell us a little bit about what is capacitive touch? I think before we actually talk about how do you implement it, it's always good to kind of refresh ourselves on what it is.
Okay, yeah. So let's go back to Physics 101.
Okay.
So everybody learns what is a capacitor at that time. So this is a very simple example for a two-plate parallel capacitance. So we have two conductive plates. The capacitance of these two plates will be determined by the distance of these two plates, the area of these two overlapping area of these two plates, and also the material between these two plates. So water you see on the slides that water has 80 of the relative constant dielectric, which has a huge impact on the resistance. And that's part of the reason why capacitive touch works, because our body are made of mostly the water. 80%, 70% of water from our body. Okay, so that's the basic theory of how it works and why the capacitive people can adding capacitance to the sensor.
And when we take a look at this simple equation here, so the area A becomes the tip of your finger. This is what is coming close to the touch button.
Okay.
Then we have the distance. The distance is the distance between the touch button and your finger, which is getting smaller and smaller.
Okay, yeah.
And then the epsilon r, which is the material in between, at the end of the day is the surface, the surface material of your housing, of your product. Yeah. So all these pretty abstract equations, they have a pretty real
super real immediate application. No, I always learned better when I could actually do it, and I didn't just have to read in a textbook, so that's awesome. So before we kind of get into the technical programming side of things, we covered a little bit about mechanical layout, but if someone were to get started with this tomorrow, or right after this live stream, they go out and they're like, capacitive touch, let's do it.
Yep.
Where are some resources that I could use to kind of learn how to design my own, like the actual physical part of the capacitive touch sensor?
Okay, so yeah, there are two parts of the design for capacitive sensor, like you said. One is mechanical hardware layout part. The other is the controller side. You have a firmware, or you have a turnkey solution that you have to access the information to. So on the hardware side, we do have a plugin within Altium Designer, which is
nice.
a professional layout tool, and Microchip work with Altium. We have a plugin that has all kinds of different capacitive sensors, including buttons, sliders, wheel, also the surface that we just see on the headphones.
Oh, awesome. And I know with Altium, I believe that they have a student license as well. So if you're in school and you don't have the money to pay for a full Altium license, you can still get access to that through the student licensing, and different universities obviously do that differently. So
if you are a student, you should also read the application note.
Yeah.
So
Yeah, because you want to learn.
exactly.
And at the same
when
time,
I was a student, I didn't want to read the application note, but some people enjoy that.
yeah, we do have an easy route that we do publish all the Gerber files,
Oh,
which
perfect.
is a design file for all our demo board that you can have a reference to your own design. So basically, you can do some simple copy and paste and do some modification that fit into your own design.
Cool. And what is a Gerber file, just in case somebody doesn't know what that is?
Yeah, so that's a manufacturer file for the PCB manufacturer. So
Okay,
it's basically a diagram or a plot that for the machine to manufacture the PCB.
It's a worldwide accepted common language for describing a PCB.
Okay,
So-
cool.
Yeah.
Sounds good. And PCB is printed circuit board. I think most people that are watching a live stream know
Should be,
that, but just wanted to clarify that as well. Great. So we talked about the physical and kind of the physical layout. Now let's jump into the firmware. And I think you have a demo for us today to kind of demonstrate how easy it is to get up and running from the programming side of things.
Sure, yeah, absolutely. So yeah, today the demo, we're gonna be using our the water tolerant surface touch kit. And we'll also be giving away this kit, 5 kits, like Rachel said. So this kit has 2 portions. One is the touch button on the lower corner. So we have button 1 and button 2. When you touch, the LED will light up. Okay. And these also control the mode for the trackpad on the other side. So for the first mode, if I touch the trackpad, the LED is tracing my finger position.
Okay.
And the second mode is called gesture recognition mode. On this mode, you can do a gesture on the trackpad and then recognize the gesture, and the LED will have some representation of the gesture. So for example, if you do a tap, all the LED will just blink once. If you do a double tap, it will blink twice.
Okay.
And if you do a wheel gesture, the LED will just do in a wheel motion.
Cool.
And then you can do a swipe. The LED just do a quick following with your finger. And you can do the dual finger gesture as well. So like 2-finger single tap. So all these LED will blink once, plus this LED on the other side.
Okay. Cool.
Right.
And these are all things that I would use in like a practical application, like we were
Right.
saying, taking it back to the headphones,
This
right?
is exactly, this is a 8-bit microcontroller doing all these functions at the same time. And this is what we have here in a real-life use case.
I love
So
it.
this swipe up thing is volume up.
That's awesome.
Yeah,
It
that's it.
sounds like we got a question in the booth.
Absolutely, we do.
Yes, we do. This is a question from Fabian. He asked, is mTouch still used? And I was wondering if you could just tell us a little bit about the different device families.
Yeah, this is a good opportunity to talk about, I'm sure everyone in the chat has heard of qTouch and mTouch, and they're kind of, wondering what the difference is between the two and things like that. So if you guys could shed some light on that.
Yes. No, mTouch is alive, qTouch is alive as a functionality. We, from a marketing perspective, don't try to use these terms anymore because they try to divide our product portfolio, which actually united. So we have a unified Microchip touch library which works on a lot of MCU families,
Okay.
on PICs, 8-bit, AVR 8-bit, and on PIC32 devices
Okay.
and SAM devices, which would be 2 32-bit core
Great.
devices.
Perfect. Yeah, so definitely still supporting both. I don't know if that that was a fairly simple answer. I don't know if you wanted more, or is that kind of what he was asking?
I think that helps shed some light on it.
Yeah,
Cool.
it does. Thank you.
Great. Awesome. So we've got the demo. How do I make it happen?
Yeah, so this demo is basically hardware design. So we have predefined hardware design. The next step is using the software library to activate all these sensing electrode and then reading out the information. Okay. So today we're gonna use MPLab code configurator
Okay.
on our MPLab X IDE. So for people who doesn't know MPLab X, that's the integrated development environment for our all our MCUs. Now supports PIC 16, 18, the 16-bit, also 32-bit controllers.
Great. Sounds great.
And for sake of simplification, what we will do now, we will do a live approach, starting from 0, creating the code for controlling the buttons.
Okay.
And
Cool.
also to show you at the end our touch tuning tools. So all these, when you do touch, you have to tune it afterwards for sensitivity and
Sure.
whatnot. And there it's really helpful if you have like a UI, a GUI to show you the sensitivity and the raw data. This is all part of our suite, and we do the whole story until we see the buttons and the raw data on screen.
Awesome.
Yep.
Excited to learn.
That's a simple plan.
Right. So now everybody sees the MPLab X IDE. So I have created a project for this PIC microcontroller. It's PIC 16F 18456. Okay. So hopefully everybody is familiar with the MPLab IDE and MCC at this point. But if not, I think, Matt, we do have a previous live stream talking about this
Yeah,
topic.
we've got live streams, we've got a wiki, we've got a lot of stuff, and so we'll make sure to include all that in the description to this video. But for sure, if you don't know it, if you have no context for what's going on right now, you can still understand it by following along, and then afterwards, if you want to kind of know what's behind the magic, there's a few great live streams and different things like that that we've talked about in the past.
Sure. Yeah. Okay. Let's
Just to clarify where we are, so we just told the system so far which PIC are we using or which MCU are we using, and we told it that we want to do touch. We didn't wrote any line of code. So
Okay.
we really start from scratch.
Yep.
Sweet.
Cool. All right. The first page is gonna pop up when you open up the MCC. It's gonna be the system module. So on this module, you will configure the system clock. Okay. So this is very important for touch because everybody wants a very fast response on the touch buttons, and so one of the factor or one of the things that will determine the speed of the system will be the system clock. So we
Okay.
always want speed to be as fast as possible to process information.
Is there like a minimum industry standard frequency that my micro needs to be able to run at to do touch well?
Yeah. So on the PIC microcontroller, we always recommend the frequency to be more than 8 megahertz.
Okay, cool.
So if you do have a configuration that is lower than 8 megahertz, the MCC will have a notification window tell you that you will need to bump up your speed.
Okay, cool.
Okay. Right. So once we configure that, the next step is going to be we will load mTouch library. So from the device resources, you can double click or click the add icon here. Okay. So once you add it, the mTouch will be under the project resources, means that the controller is now using this library. And when you hit the generate button, it will generate the library code for this application or for this solution.
Cool.
All right. Right. And the next step is to configure the sensor for your application. So today we're going to configure the 2 buttons on the board, and the step is you will go back to the schematic of your design. So
Okay.
on this one, we do have a schematic for the 2D water tolerance kit. So the 2 buttons will be connected to RB0 and RC5.
Okay.
These are the 2 pins that goes to the controller.
Okay, great.
To give this a more general view, what you need is a code configurator.
Mm-hmm.
So what the expectation is that you tell the code configurator what you intend to do.
Okay.
In our case, we wanted to touch on these 2 buttons, which
Mhm.
are connected to these 2 pins.
Great.
And that info is what the code configurator needs.
Awesome.
So configure the code for doing exactly that down the road.
Totally. And so this is saving me having to go out and figure out like what pins to set and what latches to set and all that kind of crazy stuff that,
Exactly.
especially when I'm getting started, I don't have time for. And nobody got time for that.
Yeah.
And that's not a focus when you're doing the touch. You want to be doing touch, not to just doing I/O manipulations.
Yeah.
So, all right. So let's go back to the MCC, and then we can do also a graphical configuration on this package as well. So when I think we said RC5 and RB0, right? So RB0 and RC5, right? So RB0, just right-click on the pin, and then you can select mTouch output CS. Okay, that CS means capacitive sensor.
Oh, okay, cool.
And then the other is RC5 here. So doing the same thing, mTouch output. Okay. So now we have two hardware sensors now listed here. So these are the two sensors. And in order to get a button, so you have to create a two button under the button tab, and just create two button.
Wow,
select
that's easy.
two, yeah. And even the code configurator will link the sensor to your buttons.
Oh, wow, okay.
And the reason why we have this step is with two physical sensors, you can do a lot of things, just more than buttons. You can do a proximity sensor with two sensors. You can do a slider with two sensors. But in this case, we're going to do buttons.
Okay.
That's why we have these two steps separated.
Yeah.
Great.
So in the first step, you tell the system which pins to use. In the second step, you tell the system what you want to do with these pins.
Okay,
So
cool.
in this case, two buttons, there could be a slider.
Yeah,
It's just
yeah,
it's depending on your design what you need.
totally. And just one highlight that I remembered is, if you jump back to his screen real quick, that package, so you see the package on the left, and package just means kind of the like what the physical container that the microcontroller is in looks like. And so if you have a package that's different, you can actually change that, which you can show if you want.
Yeah,
You don't have to
so
highlight
here-
it, but that's a great thing to just keep in mind. Fun development tip, I guess, pro tip you could call it.
Yeah. Yeah, that's really nice. If you have the same layout on schematic, you can just visually see where the pin is and just make it easier to locate the pin. Okay. All right, so once we configure sensors, you can see we have a different parameter for each of the sensor, because at the end of the day, a capacitive sensor is an analog sensor. So you have a lot of things to tune, but in our design, so Microchip trying to make everything is trying to be auto-tuned or automatically tuned. So there are very few parameters for now. We have some threshold, scaling factors, and these may be things that people are not very familiar with when you first get into the touch. So we do offer a very extensive help documentations on our website. So the way to get to there is you can right-click anywhere on this MCC, and there's an mTouch help.
Oh, nice. Okay.
And if you click, this will open up a new window, have an introduction of the library,
Okay.
and also the external link will go to a user's guide.
Oh, sweet.
And this will pop a browser window, goes to microchipdeveloper.com, where we have all the information you need to get the deep dive into these code configurators.
Okay, cool.
Okay.
So I can kind of run through the demo quickly, get it up and running, and then when I need to actually start understanding what I did, I can
Exactly.
go to the wiki and jump in.
Yeah.
You will find more deep dive information there, but also what we do right now is like a 10-step process to get your first button
Oh,
done.
cool.
And also that 10-step process is listed on Microchip.
It's got everything.
Yeah, that's my favorite part. It's called the step-by-step tutorial. So you have this screenshot of every step, so that you will be able to follow along, even though you're not very familiar with MCC at this point.
Perfect. Sounds like we got a question in the booth.
Kind of ties into what you guys were talking about, but Ryder Schneider asked, where can I get your evaluation boards and sample projects code?
The evaluation boards will be on Microchip Direct.
Okay.
And the code is maybe most easy to find through the web page of the development kit.
Okay.
So every development kit has a web page, and then there are resources, and there you get the source code, the gerber files we talked before, and sometimes even more source code if one demo can allow you to use it in 3 different ways. We give you
Oh,
3
nice.
different projects
Oh, cool.
to start from.
Yeah,
And
And the other thing is, if you really want to get the code, but at the same time to play with it, the other way to get it is from the website that we just showed, microchipdeveloper.com. The step-by-step example actually do show the source code you have to write to your project.
Okay, cool. And is there kind of like a touch homepage or something like that that people can go to as well?
That is very straightforward, microchip.com/touch.
Perfect. I was hoping. Past live streams, it's been /security, /32-bit, so I'm glad there's
Yep.
some consistency.
We try to make things simple.
Yeah, absolutely.
We actually have another couple of questions before you guys continue
Right.
that I think would be really good to address on the live. Both of them are actually from Pablo. I'm not going to try and pronounce his last name.
Safe move.
There was a question about, and I'm reading this from my phone, calibrating, about the ability to calibrate the interface, the touch sensor, so that you can sense touch from behind different surfaces, like, for example, glass.
Oh, that's a great question.
Yeah, so that will link back to our debugging tools. So we do have a real-time debugging tool that we're going to show after this code configuration. That in that tool, you will see how much sensitivity do I get, and then I can play with my parameters and see, oh, what's the effect when I change these parameters.
Oh.
So because different size of button, different thickness of overlay will have an impact on the sensitivity.
Okay.
And
Cool.
basically, the hands-on approach is you start with the default settings, then you take a look at your tuning with our visualization,
Yeah.
and then you see, touch is detected, but by barely half a digit.
Oh,
So
yeah.
you might want to get a little bit more headroom in order to be noise sustainable and so on.
Sure, sure.
So in summary, it's more of it's an iteration of tuning.
Okay.
So
Exactly.
if you
Cool.
change the process, you have to retune, but we do provide tools that just make things easier for you.
Sweet.
Very cool.
Sounds good. Awesome. So after I've
Oh,
looked
Wayne,
at
did
my
you say
wiki-
this was a twofold
Oh,
question?
that's right. you
Yeah,
did.
the other part, and actually this is something that kind of got answered in the chat, but the question was around where the libraries exist. Are they in Harmony and MCC? What level of support do we have for?
The question contained the answer. So and we have 3 code configurators today. We have MCC, we have Start, we have Harmony, and the touch libraries are in all 3.
Okay.
Oh,
Perfect.
Yep.
Wow.
Yes, Rachel.
We actually just got another question. Will there be a visual debugging tool for Linux?
Ooh.
That's a valid question. I think the short answer is yes. I cannot connect the time with that. So we use today Data Visualizer, which exists on Windows platform.
Yeah, Windows only. Yeah.
I think I'm talking too much right now, but there will be an update to Windows, to Windows, I guess. But I'm talking about Data Visualizer here, and there will be an update to Data Visualizer, which makes it basically web-based and therefore then platform
it's
independent.
cross
Yeah.
platform. Yeah.
So it's coming.
Yeah, it's coming.
Coming to a computer near you.
Right.
Thank you.
Great, thank you.
So let's go back to the configuration. So like we said, we have an interface that can debug our process, debug our touch. So the way to enable that is we go to the debug tab here, and you just have to enable the debug, right? And the way we transmit data to the PC GUI is through the COM port, the UART. Okay. So one extra step is trying to make sure the UART TX RX pin are connected to the right pin on your board.
Yeah.
Okay. Still the same process. We go back to the schematic of our board, and we do see here the RC7 and RC6. These are the TX and RX pin on our controller. So we just want to check if this is the same here. So RC6 and RC7.
Looks good.
Right, looks
Sweet.
good. Okay, so at this point we can generate the project.
So basically what we did is we told the system, use these 2 pins for 2 buttons.
Okay.
We activated debugging that we can use our data visualizer, and we told the system which UART pins are used in our design. So that's what we understand about code configurating, telling the system what you intend to do,
Okay.
and then getting the code as a result.
Sweet. Sounds good.
All right.
And when we say getting the code, I think one clarification that I always like to make is what you're getting is the initialization files. So you're getting all this stuff that you would have had to write anyways, but it's not going to give you like your specific design oriented thing, but it saves what 50-60% of the process, even more than that, because you get all this stuff that you would have had to write anyways. It's kind of like the boring, like just to get everything set up, it's giving you all of that stuff. So that's what we mean when we say it's giving you the code.
Yeah, so once we generate project, these files will be placed into the project of your MPLab X project. And we do get an empty main file, that's like Matt said. It doesn't write application code for you. It just generates all the libraries and initialize files. So you have still to write a few lines of code just to call the functions and get everything going.
Right.
Right. And then people will ask, okay, which function should I call? There's a big library and you have a lot of functions and it does a lot of things. So we do provide a mTouch API example after we generate the code. And in this example, it will show you what exactly you have to call in your application. Okay. And
So this is part of the generated code.
Okay.
So you don't have to find it somewhere. If you generate more complex code, you will get a more complex example.
Gotcha.
Exactly.
Cool.
And this is, tailored to your application. Even the example code is tailored to your application. So if you only have buttons, it will only generate the button API.
Okay.
API means application program interface.
Okay.
All right. And if you have surface, you have slider, then this will be more of this API generated for you. And we do provide the link again to the Microchip developer help that goes to the more deep dive, more extensive documentation for the APIs. Right. Okay, I'm just not gonna call the mTouch service main loop, and that will be placed in the right here. So just let you know that if you have buttons, you want to control the button, the button is pressed, that's the API to call if you want to read out the button information. Since today we're going to use the GUI to see the button state, we're not using this API, so I'm not using that in our today.
But one thing I want to highlight is the API is written, you can just read this like English. I mean,
yes.
mTouch button is pressed. Even if you never wrote any C code, you get an idea what this function might do. Right. So that's another benefit of using the code configurators. You end up with readable code.
Totally.
Yep. And one thing that just don't forget is we have to enable the interrupt, because our touch do use interrupt to give a high performance non-interrupt. So you can run your main code, but the touch will run at the back side. Once the touch is done, then it will generate interrupt to notify application that my touch is finished. Please process the data.
Okay.
Right.
Cool.
So just a way to minimize the CPU resources. Okay. And then once that's done, we can do a program. First, we'll compile and compile successfully, and then we do a program to the board.
So here our actual main file is one line of code, which means do the touch sensing.
Yeah.
And then we already enabled the data streaming, so this is all we need to do. That one line of code will feed into our data streaming code the touch data.
Okay.
And then we use our GUI to visualize that.
Yep.
Okay, cool. And just the example code, what it's actually doing is the button pressing, correct? Like press the button and the LED comes on, or is this a different example code?
The code we just wrote just reads out the button status.
Okay.
And then we enable the debugging, which means the button status will be pushed to the UART.
Gotcha.
There will be no LED switching in that code.
Okay.
If we would do LED switching, then we would have this if statement. If button is pressed, switch on LED.
Gotcha. Okay, cool. Thank you for the clarification.
You're always welcome.
So this is a tool that we're going to use called a data visualizer. I think if people watch the previous live stream, they have used this tool for other applications as well. So, so we will find at the COM port 885 for this board, and we just do a connect. So before we do connect, usually we'll go to the project and then find our touch project and then select the folder, because the folder contains the protocol that will communicate to the board.
The what?
The protocol.
Protocol?
Yeah, the communication protocol.
Oh, protocol.
Sorry.
I mean, it's when you, let's say you do a touch surface. This is a 5x6 matrix. So you would have to transmit 11 data points
Okay.
continuously. Now we
Gotcha.
have only 2 buttons configured. We only configure 2. You need to make a connection between what is the content of the data stream
Okay.
to the visualizer. You say, okay, I get a bunch of data, but what does it mean?
Yes, yes.
And that connection is also part of your generated code.
Gotcha. Okay, cool.
All right.
So that what you see here is a result of your code generation.
Yeah.
Okay.
And first of all, it seems like nothing happening because I'm not touching the button. Now I'm touching the button. You can see the
Oh,
red
look at
plot.
that. Wow.
Yeah. And then the button state here indicates when it goes green means the button is pressed.
Oh, nice.
And then I
Okay.
can do the same thing for the second button, the blue one.
And that yellow line at 100, that's the threshold that you
That's
set
the threshold.
before?
Exactly.
Okay,
Exactly.
cool.
So once you change that in your MCC, the code configurator, this will be changed as well. So to reflect on the the GUI interface.
Okay, awesome. And where can someone find the data visualization tool? Is that part of MCC, or like where do they get that tool?
Yeah, so it's a separate application. For now, it's a part of it can be a part of the Atmel Studio.
Okay.
So after you download the Atmel Studio, you get the tool. But there's also a standalone version that you can download.
Oh, great.
For me, the easiest way is that if you use the Touch, and on the Touch MCC page, we do provide a link. So if we can go back to the computer page, yeah. So once you go to the debug, there is a download link.
Oh,
You
nice.
can direct
Right there.
That's so easy.
tap the button and goes to the standalone version.
Okay.
Then you can download the software. You always go to the latest version that we have on the website.
Perfect. And is this the tool that is only, what OSs does this support?
So for now, it's only on the Windows side.
This is the one that's on the
And
Windows,
Microchip is
okay.
working on put this on a cross-platform.
Okay. Online.
Yeah.
Yeah.
Okay,
Yeah,
cool.
exactly.
It sounds like we have a question in the booth.
Man, you're really quick at picking up on that.
You
I
know,
tell you.
fastest draw in the West.
Ah, good job.
Jared was wondering, does the mTouch library require a specific hardware module?
And in hardware module, I think we came to the agreement that I think he means peripheral.
Yeah.
Jared, if we're wrong, then just let us know.
That's a very good question. So we wrote the library in a way that the minimum thing what you need would be an ADC.
Okay.
Our recommendation, though, is to use an MCU with a touch peripheral,
Okay.
which is still an ADC, but the ADC has some logic around it to do the touch more in an autonomous way,
Oh, nice.
which
Okay.
helps you. Let's say you program your actual main code, and there might be some time critical functions there. You don't want to get interrupts constantly, and so you bring the touch sensing to the touch peripheral. The touch peripheral is doing the touch, and only in case someone touches your board, in that case you get an interrupt to your main code.
Gotcha.
And then you need to interrupt because if someone touched something, you want to react on it.
Yeah.
So you don't necessarily need a touch peripheral, but if you do more than touch on an MCU, it really helps you to write your whole code.
Sure. Okay. Cool. Great question, Jared. I didn't even know that. So that was a good question.
Thank you.
Great. So that's a little bit about how to set that up, and then not only how to set it up, but actually how to debug it and stuff like that, which is a really great piece to it. What's this other thing that you have here that it looks like you wanted to show us today?
It's just by chance it's here on the table, but now that it's here, we can also show it. So we are talking touch here. This is an 8-bit microcontroller, was doing this touchpad and the gestures and everything. If you go forward, if you step onto this is a 32-bit controller here, and that display and the touch on display and the content of the display itself
Okay.
is controlled by a single MCU.
Oh, great. And
So
what's that MCU that's running on this?
That
one?
is a SAM-D51.
Okay, perfect.
So, and for instance, it's mirrored.
It's
When
mirrored.
when I look, I want to show that demo. You can play easy
Wow.
game of
That's impressive.
blocks here. Actually, it
Playing
makes
it
more
upside
sense if I
down.
turn it around. You see? And so there are some other UI examples we have here, like from a washing machine. And here, this is basically our touch library combined with a Harmony library for graphics.
Okay.
And it's all set up in a very similar way what we just saw. And then you add your application code and you can run a full machine,
Okay.
an actual product running on a single chip with a touch interface, with a TFT display and everything configured, in that case, out of the Harmony code configurator.
That's awesome. And he mentioned Harmony and TFT and the graphics. No, that's great. That's perfect. That's actually what we talked about last month. So if you're curious and you want to kind of watch this live stream, and then if you were here the last live stream, you can either jump straight into this, or if you didn't watch the last live stream, definitely recommend to go back to last month. I think it's like how to get started with 32-bit graphics or something, how to get started with graphics. We'll link it in the description as well. But that is a great resource to kind of figure out how do you go from taking these individual pieces of graphics, of touch, of these different parts of a whole system and create a huge human-machine interface type thing, which HMI is a obviously really big thing right now. Yeah, so that was a great lead into that. And that was all organic. We didn't even plan that. So,
All right.
Great. Well, I guess the last question then, and we've covered this a little bit, but let's just cover it one more time, is where do I go from here? So you've shown us a lot of great stuff today, kind of where am I going to go to get information? What are your next steps? That kind of stuff.
So basically, there are two websites to start with. One
Okay.
is the microchip.com/touch,
Okay.
where you will get an overview about our MCUs doing touch, about the use cases we solve. So it's more like let's call it the marketing side of the touch things. And then you also see the products and prices and stuff like that.
Okay.
And then there will be links on this block of pages to the microchipdeveloper.com, what Xiang already showed us. And on microchipdeveloper.com, there will be these step-by-step guides for your first touch on a PIC, on an AVR, on a SAM device. We will talk about how to do water tolerance, how to lay out a slider, what to do in very thick overlays. We had here a plastic cover, maybe 1.5 millimeter thick. What does change if I go to a 7 millimeter glass cover for whatever reasons?
Okay.
All these more specific topics are then discussed on microchipdeveloper.com.
Okay. Great. Well, that's kind of all we have. Is there any last-minute questions or anything like that in the booth?
So if we didn't get to your question, send us an email at livestream@microchip.com. But I think we kind of covered a lot of the relevant ones.
I think we covered quite a few of the topics that were in the chat.
Awesome. Perfect. Well,
I think it's
with that time, it's I guess it's my favorite time of the live stream, or
Yeah.
at least our viewers' favorite time of the live
time
stream.
for winners. Should we do the drum roll? That's probably going to mess up the microphone. All right.
So our winners are Pablo Pachaletto. You had great questions. Thank you, Pablo. Ryder
job.
Schneider, Eloy R., Ulyss Garza, and Jared Munch. Thanks, guys.
Thank you.
Congratulations.
Thank you.
Congratulations.
Congratulations. Yeah, send us an email at livestream@microchip.com, and we will process the prize for you.
Yes,
Thank
and
you.
in that email, make sure you have 2 items that we need, or 3. Your name, obviously. Number 2, we need your mailing address, complete, and we need a phone number.
The phone number always gets
That's
people.
super important for all of the common carrier services because they don't like to deliver without phone numbers.
Yes, and we're not going to use that phone number to like call you in the middle of the night.
Well, we might.
Great. Well, thank you all so much for coming today.
Thanks for having us.
Yeah.
This has been great. I learned. This is my 3rd time running through this, and I've learned new things about touch every time. So I wish I had this resource when I was in college, but we have it now. So that's the important part. Well, if we don't have anything else, I will say thank you all for sticking with us. For those of you that have stayed to the end, we really appreciate it. If you have any questions, I just went rogue.
Yeah.
There you go.
Yeah.
Turn the lights off. If you have any more questions, feel free to comment on the chat or in the comments to this video. If you want future live streams, so different topics that you want to cover, we have AWS coming up next month. So we won't be going kind of into the technical side of how Amazon Web Services works, but we will have someone from Amazon here with us talking a little bit about how to do security with AWS. So we've covered Google in the past, so this time around we're talking about how do you do security and to partner that with connecting to the Amazon Web Services. We've got a great live stream in January coming up with Mauser, one of our other partners, to talk about how to do IoT specifically in the horticulture space.
Hey, real quick, Matt.
Yes.
What's the part number for that kit?
The part number for that kit is DM164149-5.
Thank you.
No
The
problem.
dash 5 is the amount of kits we have.
Sorry,
So there's no dash 5.
no dash 5. I take the dash 5 back. But yeah, so great live streams coming up, but we obviously want to do live streams that you want to see. So if you have a request, please leave that in the comments, and we will make sure that we try to make that happen. With that, I think from all the folks at Microchip, we say good luck, great designing, and we'll talk to you soon.
All right. See you.
Thank you.